This is Chapter 8, Lesson 5. This section is based off of lateral area and surface area of cones. So try to keep cones in mind, or a visual representation of a cone, as we go through this section. We'll start you out with some important definitions and equations that are based off of what we're going to look through today. Lateral area is the area of all sides of a 3D figure, excluding the areas of the top and base surfaces. So when you think about a cone, some cones have the bottom, some do not. I think of like an ice cream cone. An ice cream cone does not have that bottom surface. So when we're talking about lateral area, that's kind of the lateral area that we're going to find. The surface area is then including that bottom section. Okay, so that's kind of the difference between lateral area and surface area. The lateral area of a cone equation is LA, which is just standing for lateral area, is equal to pi times the radius times the slant height. The surface area of a cone equation is pi times the radius times the slant height plus pi times the radius squared. So if you look at this figure right here, that's a pretty good representation of what the lateral area means. So the lateral area, it's got that little line pointing to it, but it's actually excluding the base area, which is the one I just drew the X through. Let's go down to the example. Through the example, we have a cone that has a slant height of 13 millimeters and a radius of 5 millimeters. So using the equation again, LA equals pi times the radius times the slant height. You can see they plugged 5 in for the radius, 13 in for the slant height. Okay, so when we type that into our calculator, we get roughly, and there's some rounding that's going on with this, 204.2 millimeters squared. Let's do some practice on our own here. First example has a slant height of 18 feet, so a rather large cone, and a radius of 12 feet. Okay, so I'm going to use this equation as I go through, and I'm going to replace the radius and the slant height with the given numbers for the first example. So I'm going to take and I'm going to go pi times 12, which is the radius, times 18, which is the slant height. Okay, and when I type this into my calculator, I get 678.6 feet squared. I'm always remembering my label. This one happens to be in feet, and since I'm dealing with lateral area, everything's going to be squared. On to the second example. Second example is just a little bit different. It gives us the diameter rather than the radius. So you can see the pink line goes all the way through the base of the cone. So we're going to have to divide that by 2 in order to get our radius. So still using the same equation, I'm going to go pi times radius, which happens to be 15. So I took 30 divided by 2 in order to get the radius, times the slant height, which is 6. So when I type this into my calculator, I get 282.7 meters squared. Surface area explained. We're going to use actually this equation right here for the surface area. It'll be on the next slide as well when I go through some of the examples. Under this example, we're going to once again round to the nearest tenth. So we have our cone off to the right there. We have 6.2 inches as the slant height, and we have 6 inches as the radius. So those are the two numbers that we need in order to replace those symbols within our equation. Okay, so you can kind of see where the red is replaced, the 6 is replaced with the R, which stands for the radius, and the 6.2, which is in blue, is replaced with the slant height. And then in this example, we get, when we type this into our calculator, we get 230 inches squared. Okay. Let's do some practice here. The first one has a slant height of 20 inches and a diameter, once again, of 25 inches. So remember, we need to use the radius when we go through the surface area for our equation. So our equation's right up here. So I'm going to go ahead and I'm going to replace the numbers that I'm given within the first example into the equation. So I have pi times the radius, which is going to be actually 12.5. I took 25 divided by 2 in order to get half of the radius there. I'm going to multiply that by 20, which is the slant height, plus pi times the radius again, which is 12.5 squared. When I type this into my calculator, first of all, remember to type it in with accuracy. Okay, this happens to be a little bit longer. I get 1,276.3 inches squared. The second example, I went ahead and did, I replaced the radius, wherever the r is in the equation, with 3. And I replaced the cursive looking L, which is actually the slant height, with 10. Remember to put this plus sign in between. Sometimes we forget that that's actually supposed to be a plus. We fill in a lot of multiplication as we go through finding the surface area, and sometimes we make the mistake of putting a multiplication sign instead of a plus sign there. So make sure you're doing that. When I type that into my calculator, I get 122.5 meters squared. And remember, these answers are rounded to the nearest tenth. I encourage you to do some of the practice that is going to be attached to the bottom of this video. There's going to be a skills sheet along with an answer sheet. So once you get the skills sheet done, you can check your answers. Just make sure you're paying attention to where it's asking you if you're finding the lateral area or the surface area or both. So make sure you're reading the directions as you go through those.